Perfect.
So,
thanks, Anna.
Yeah. So thank you everyone for attending and watching this video on climate change. We are delighted to be welcoming Jeff Steuer here to talk about what he learned from the Climate Reality Project. Take it away, Jeff.
Well, good morning all. And as Ann said, I'm a concerned citizen that took the training from Vice President Gore's Climate Reality program, and really have two purposes today. One is part of the training, they ask that we pay it forward, pass it along. And then number two, I'm looking to learn from you. So at the end of the presentation, I'll have my email address, and I have one or two questions that I'm going to pose, and I very much welcome your feedback on those two questions. So just a shot before we begin of this is back in the late 60s from early 70s, a shot from the moon of Earth, and I think most of us have seen the image of just how fragile and beautiful the Earth is. So looking to answer really three questions today. Address first is, must we change regarding the climate reality? Can we change? And then will we change? So must we change? Just a very little bit of science. I think most of us know that the radiation comes from the sun, strikes the Earth's surface, and of that radiation, about 50% of it roughly is absorbed on our surface. Another 50% goes back, and of the portion going back, about half of that is retained in our atmosphere, and the other quarter goes back out beyond our atmosphere. So there's been a balance going on for many years in this atmospheric layer, and what we've done over the years is change that balance. So as the CO2 concentration that we emit with our development increases in the atmosphere, we get more of the greenhouse gas, and we do emit quite a bit into this layer. This is just a shot of a sunrise, and showing how fine that atmospheric layer is, and the source of the greenhouse gases, of the CO2. I think most of us are aware that it comes from our land transportation, some of the industrial processes, coal plants are the sources of the extra CO2 we are now putting in the atmosphere that's being retained. And this is just a graph showing over time. So this is the 1850s to present day. This is the tons of carbon that is the fossil fuel that's burned per year. And the point of this graph is just want to show the rise there shortly after World War II, and the steep rise of the burning of fossil fuels. I'm going to back it up. So this is 1850, and you see this rise here at about 1950. I'm going to back it up about 10 million years. And so this is the time axis, and this is CO2 in our atmosphere. And the last ice age ended over here about 11 million years ago. Civilization, we started to form communities and all here about 6,000 years ago. And you can see how the CO2 dramatically started to rise there in about the 1950s. And you can see the CO2 went up and down a bit through natural processes, but then you see the rapid rise. And these data come from recently, after 1958. You can measure CO2 in our atmosphere quite simply. It's almost as easy as taking a person's body temperature. But to go back in time this far, they utilize long-term ice core data, and the scientific consensus behind the data, I think, is solid. So 2 points on this graph is how much the CO2 in the atmosphere has raised, and then the rapidity, just how fast that raise has happened. So that's one piece to keep in mind. And of the CO2 that has increased, again, this is axis 1800s. You see the rise of use of fossil fuels. This just breaks it down. In other words, those fossil fuels, a little bit less has been the burning of coal, crude oil, and natural gas. So one other way to look at the carbon data is put it with temperature. So this plot, again, we go 1880 to 2017. And this axis is temperature fluctuation since the 1880s, and that's this line. And of course, each year, climate is different. So you see the fluctuations, the annual fluctuations. And then this line is the carbon dioxide in the atmosphere in parts per million. And I think current day, I don't know, we're about maybe 420, something like that. But one sees that as the CO2 in the atmosphere has risen, you see the lifting of the global temperature. One other point I'd like to pass on is I'd mentioned that you can measure the CO2 in the atmosphere quite easily. The effect of CO2 has been done in many different laboratories with experiments, but you can actually do it at home pretty easily. If you take two bottles and you put one bottle with air, another with CO2, seal them, heat them up, and if you have a temperature probe in the bottles, this is temperature, you can see that the bottle with CO2 rises and retains the temperature more. So just a simple desktop experiment. So what we put into the atmosphere, the heat energy that we are putting into the increased carbon that wasn't there 100 years ago, that heat energy is the equivalent of exploding 600,000 atomic bombs every day. That's the amount of energy that we're putting in. So what are the effects? So one is global surface temperature. This is time here. If you take the average global surface temperature since 1880 and you have that number, what years were we above that average? What year were we low? So these years we were below that average for that time period here, and these years we were above it. And so the pattern is pretty clear. So those high temperatures, have affected. These are some slides from this was 2020 slide. Phoenix, Miami both experienced their hottest months ever in July 2020. I think in the news now, it's we're experiencing all across the U.S. high temperatures, but this is also overseas. This that this Paris, France had its record in 2020, and who is most vulnerable to the heat? Oftentimes, it's the poor and the homeless, the elderly, infants, folks with pre-existing medical conditions, agricultural workers, and folks with outdoor jobs. And again, it's overseas. Ghana set its record temperature last year, 2020. Siberia, June 2020, reached its record temperature. And a little more closer to the Midwest, this is just a graph of winter minimum temperatures for Minnesota from year 1900 to present. And you can see the trend of increasing winter temperatures. So of this rising heat, a lot of it is transferred to the ocean. And this is a similar graph for ocean temperatures. If you took the average ocean temperature from 1960 to 2020, what years were we lower than that temperature, that average temperature? Well, you can see the pattern. These were the years it was lower. These are the years that it's higher. So ocean temperatures have trended higher also. As a result of warmer temperatures, the strength of hurricanes are greater. This is a shot of a path of Hurricane Harvey there, and it moved across the Gulf, where the Gulf was 7 degrees Fahrenheit hotter than normal. The effects of the hurricane in Lake Charles, Louisiana, of Hurricane Laura. Pensacola, this effect from hurricane, and This is a shot of an amusement park in New Jersey, the effects from Hurricane Sandy, I think. So, and effects are overseas. Hurricane mudslide in Guatemala, 2020. Refugees from the hurricane season in Central America. So there's a wide range of infrastructure that's at risk from extreme weather. I'm not going to go through all of this in a 30-minute presentation, but much of our infrastructure is affected by it. And in a letter from Pope Francis, it said some gravest effects of environmental extremes are suffered by the poorest in the world. This is a shot of the flooding in Louisiana. The flooding affected disproportionately Black neighborhoods. And as temperatures increase, the oceans evaporate more water into the sky. And as a result of that, let's see how we're doing here. This is a satellite shot of movement of water in the atmosphere from Hawaii to California. I think this next one is a moving shot of atmospheric water coming into the West Coast. And with such concentrated water movement, you end up having very intense rainfalls. You see this one over Phoenix, 2016, this one over Montana. Vice President Gore is from Nashville, so he had this one in his presentation, some flooding in Nashville in March. And a little closer to home, flooding from an intense rainstorm in Minneapolis in 2019. I worked as a water engineer for the U.S. Geological Survey for 21 years, and back in '97, I had a temporary detail to measure the flooding that went on in the Red River, and it was phenomenal. We were measuring the flow that was going through and around bridges, how many cubic feet or how many gallons a second were moving through, and it was an amazing situation to see barns completely underwater. And the flooding this is a slide just pointing out that U.S. farmers were prevented from planting 20 million acres in 2019, much due to heavy rainfall and flooding. And this is a shot in Nebraska of flooding and effects on agriculture. And now globally, floods and extreme rainfall events occur more often than they did in 1980. This is a shot of a mudslide, so the effects are overseas also with these more intense rainstorms. In India, in July of 2020, they had just under 2,000 deaths from intense range from the monsoons. This actually a shot from in Argentina of hail, of intense hail that I think these folks, they use some chainsaws to cut out the cars. And they've been finding more intense tornadoes have been happening. And that same heat that evaporates more water, causing bigger downpours, that same heat pulls moisture more quickly from the soil, causing longer, deeper droughts. I think you're aware of the drought that's going on in Western US. This is a shot of a riverbed in Brazil in 2020. This is a slide, this is April this year, showing the drought in the Western US, which has continued. And the drought conditions have its effect. In Europe, this is a slide of the groundwater levels, which reflect infiltration and rainfall. So along with the higher temperatures and the droughts, fires become more common. the fires have been getting bigger and hotter, lasting longer. 5 of the 6 largest fires in California occurred in 2020. Fire devastation in Oregon last year. And Vice President Gore put this slide in the presentation just to point out that we can't allow this to be the norm. You get people playing golf with quite a blaze going in the background. We can't allow it to be the norm. And fires are increasing overseas. These schematic of increased fires in South America. A quote from the Greece Prime Minister that the toll is taking on Southern Europe. So we've affected the balance of the hydrologic cycle, and the Department of Defense has concluded that climate change will likely lead to water and food shortages, increased disease, and refugees. And this is a shot of refugees in Croatia. They're Syrian refugees, and the Syrian situation has been unstable for years, but climate and the drought there has had an effect on the refugees. This is a slide just showing the projection of soil moisture, and if we don't change our carbon emissions, the effect of the dryness and where that some of the driest areas will be, which is in Central America. And zooming in on that, you see the real affected areas are projected to be El Salvador, Honduras, and Costa Rica, with Honduras ranked #1 of the countries on the risk index, and Nicaragua being shortly behind that. And the quote from a academic who had stated that one of the main reasons people are moving is they don't have anything to eat. So just a touch more science. So in general, climate takes temperature generated at the equators and moves it to the poles. And that movement of temperature is what sets up both the ocean currents and the air currents. I was in the Coast Guard down in Miami for 3 years in the early 80s, and the Gulf Stream and the movement there along Florida is well known. So that's this movement of temperature from the equator area to the poles establishes these currents. And the other factor is that a 1 degree change at the equator is reflected in a 3 degree change at the poles. So it's magnified, and it's really not certain what that kind of change is going to be doing to the established atmosphere and ocean currents. I think it's trying to be understood, but I think there's some question as to what it's going to do about it. So the increase of temperature at the poles, this is a picture in 1935 of a glacier in Greenland. You can see the glacier extended down here, and this is a more recent photo, 2013. The glacier's melted there. We do see the tongue there. This is a graph of the loss of the ice mass over time from 2000 to 2020. About 5 years ago, I was hiking and traveling by bus in Peru, and I was in a small mountain village where folks live by the farming, and they depended on the summer, the seasonal melting of the glacier for water for the crops. So the glaciers would melt and partially melt in the summer, and then typically in the winter be reestablished, and they counted on that melt runoff cycle to water the crops. But the glacier was getting to the point where it was nearly gone. It wasn't being reestablished, and there was very much concern as to what they were going to do for water for the agriculture. There wasn't an easy routing or water or technological fit for them once the glacier summer melt was gone. I was in the Coast Guard for 9 years. This is on a buoy tender icebreaker. And this is a shot of our buoy ops. But I put this in here because, although ice is critical at the poles to the wildlife and the ecology, ice is often just plain beautiful. This is a shot of some pancake ice when we were underway. A shot of the North Pole of ice mass change. This is 1984. This is the size in 2016. Some of the oldest and thickest ice had never been observed to be broken up, and it happened twice in 2018. It's melting faster than originally thought. And this is a graph when the ice mass at the poles melts, it rises, has sea rise. This is a shot of cities at risk by assets at risk around the world. You can see Miami is here top on the list, with the New York area being right behind. This is a shot in Miami of flooding in a parking ramp. They ended up having an octopus in the parking ramp. Overseas, the rising seas has an effect. Kiribati is one of the first, I think it's a Pacific island nation that, because of rising seas, they've had to purchase land in another country to house its citizens being forced to move from sea level rise. So climate does affect the food chain. We've talked a little bit about the drought effects and the flood and the fire effects. It's thought to be that climate change will be one of the larger, the biggest global health threat of the 21st century. It affects health in many different ways. I'm going to talk a little about air pollution. I'm not going to cover all of these. A little bit with infectious disease. This is a graphic showing diseases attributable to air pollution, particulate. There's over 9 million deaths a year globally due to air particulate. Here in the U.S., coal plants certainly have put out particulate, but along with the particulate, they put out mercury. The USGS colleague who spent his career studying mercury in water bodies and in the food chain. And I think most of us are aware of that mercury accumulates in the food chain. And this shows that it's triple in the oceans. And I think most of us are aware that women of childbearing years need to be aware of their fish consumption due to mercury. Tropical diseases are on the move because of the increase of temperature in the northern and southern hemispheres. It's allowed movement of disease. Closer to home, 30 years ago, it was felt the mosquito season in Minnesota was just about 75 days long. Now it's assessed to be 108 days. Tick-borne diseases has doubled over the last 15 years. Mosquito-borne infections have increased in the U.S. So the cost of carbon is substantial, and it's a cost it's not acceptable. Not acceptable to lay it on the newest generation, and it's a threat to the cost of carbon is a threat to our economy. So must we change? Yes. And I go back to this slide one time because I think it's an important slide that, it's, again, very easy to measure CO2 in the atmosphere, and the effect of CO2 is readily seen. Again, this was a little experiment you can do between air and CO2. So can we change? That's the question. And we have the solutions at hand, so we're not doomed. we're not doomed. We have control of our destiny. There's been some recent calculations, October 2020, that shows that the lag between halting CO2 emissions and the rise in temperatures may be as little as 3 to 5 years. What that means is that if we could halt let's say our CO2 level, and again, I think we may be at, I don't know, about 420 or something like that present day. If we could hold it at that now, the temperature would rise for another 3 to 5 years, but not the 25 to 30 that was originally felt. And that's due to, they've discovered that that the oceans can actually sequester, can store carbon more rapidly than thought. So the turnaround time is not as dire as was felt. Well, how will we stop the rise of CO2? One is wind capacity. Wind capacity was felt to reach 30 gigawatts by 2010. That was a projection in 2000. Well, the reality was that by 2020, we exceeded that by 24 times. And wind is this is a graph of wind energy that's generated in the U.S. You can see the change from 2001 to present day. Germany is producing currently over 50% of its electricity by renewables. And in general, wind could supply the worldwide electrical need 4 times over. And actually, I think offshore wind, not in the US, but offshore wind globally, I think is one of the fastest growing energy sources. Solar. In 2002, it was projected that it would grow by 1 gigawatt per year for 10 years. Well, the reality was it exceeded that by 17 times greater than was expected. And in 2020, it was exceeded by 132 times. So the solar, this is a graph of the price of solar panels showing how much it's come down since 1976. This is the solar capacity, what's being generated in the US, showing the rapid increase from solar. And in general, there's enough energy from the sun every hour that comes to Earth that if you could capture it all, which you can't, but there's enough reaching the Earth that the entire world's energy needs for a year strikes the Earth every hour. The storage capacity is certainly important. This shows the global storage capacity for 5 years, the increase. But this graph shows the projected storage capacity over the next 40 years from where we are now. So the technology for storage capacity is greatly increasing. This graph shows over time, so this 1970 to present day, how much energy was generated and consumed from coal production. You can see it sort of peaked here around 2010. This is the consumed energy that was produced by renewables, and you can see the increase here and about the equivalent generation here in 2015, 2020. This is, to me, was a real insight when I took the course. This is the cost of generating electricity, producing it for different modes of production. So from 2010, 2020, the price to produce energy with coal was pretty steady. This is the cost to produce energy by natural gas. This is the cost to produce energy by nuclear. It's gone up for a couple of different reasons. This is the cost to produce energy by wind. So you can see it dropping down. And this is the cost to produce energy by solar. So here in the last couple of years, it's cheaper for an executive of a power company, if they need to put on extra power capacity, it's cheaper for them to build solar fields than it is to produce a coal plant. And this is just a quote from energy CEO in January this year that there's not a regulated coal plant in the country that's economic today. And this is just a finance graph. It shows the energy sector index as compared to the S&P, showing that it hasn't been the traditional energy, conventional, haven't been a good investment over time. And the investments in renewables create more jobs, 3 times more jobs than fossil fuel technology. And it's going to affect coal miners for sure. And they need to be thought about in the shift over as far as being retrained in a field that's going to be safer and better for their health. And this is a shot that Vice President Gore had in his presentation about the coal mining museum in Kentucky. They've used solar panels on their roof, giving them a cost of about $10,000 a year. And you know, in the U.S. Currently, there's nearly 5 times as many jobs in solar than in coal mining. So one of the aspects I hadn't considered before taking the training is that renewables can be a means or a tool for global social justice, in that, you know, you can put up a panel and generate electricity for whether it's a computer or day-to-day devices that you don't need a developed grid. You know, there are a lot of areas in the world that didn't have a stable government, didn't have a government situation that could produce infrastructure needed for power grids and all that. This is a shot in Sierra Leone of laptops being powered by small solar panels. So as far as a commitment to go renewable, you know, over 290 global companies have made that commitment. This is just a list of some of those companies that have committed to go renewable. And more local, 3M is one of those, has committed to go 50% clean by 2025, 100% by 2050. Auto manufacturers are moving to electric cars. You know, 3M has announced it would phase out their combustion engine for passenger vehicles by 2035, not that far off. Shot of the Volvo electric car and a shot of Tesla's electric truck that has substantial mileage range and fairly economical to run. This is the amount of cars on the road, the electric cars, global on the road. And as far as speed of transition, you know, there was the agricultural revolution, took quite a bit of time and really changed life. The industrial revolution took time and really changed life. The digital revolution was much faster, and obviously has changed our lifestyle. And it's felt that the sustainability revolution has the capacity to really change quite rapidly. So can we change? Yes. And I show this graph again because the can we change, you know, right now, just the blunt economics allow solar and wind to be an economic way to run our economy. We have the technology right now to do it. So the question is, will we change? And you know, we had the Paris Agreement in 2015, in which we've recently come back on aboard. But is there any precedent for such a rapid change? Because we do need rapid change. Many of you may have been reading about the recent global report that came out that was synthesized from 14,000 papers over the last 5 or 10 years and been approved by the nations of the UN. So, but is there a precedent for rapid change? And one possible example may be the cell phone. In 1980, AT&T projected 900,000 users for the year 2000. Well, it was actually exceeded by 120 times. That, but in year 2000, there was 109 million used, and currently there are 10 billion cell phone connections. So they weren't just wrong; they were way wrong. This is a picture of Vice President Gore on his cell phone back then. So why did it change so quickly? Well, the cost dropped sharply, as we're seeing with panels and wind. The quality of the phone improved dramatically, and the low-income nations without the landline infrastructure, they just skipped the old technology and they went to cell phones. So this is a graphic of showing the cell phones usage. You see time here, the subscriptions here, and you see the developed country in blue, countries, and the cell phone countries, cell phone use and developing in green. So the undeveloped countries, the developing countries really jumped on the technology. And again, it was that they didn't have to have that kind of established infrastructure that a stable government produced. And I think the solar and wind to some extent has that ability. So just a shot to show that it can really be localized. Just a shot of a solar setup in South Africa. And so young people, around the country are calling for change, and that because it's really their generation that is going to be affected most greatly, and overseas there's people pushing for change. So for yourself, I ask you to just talk about this with your neighbors and your friends, and when you vote, keep it in mind when you vote, and with your life choices, give it some thought. We just Amy and I just put panels on our house, and it's been working out great. So my reason for taking this course, the 4-day course, was for my family. It's a shot of my wife Amy and my 2 daughters and Casey, and it's a shot of Beth and her husband Mason, who they're expecting a child now any day. So I'm doing this for them, but also I said, I had 2 questions, 2 requests for you, and the first one is after, and this is not in person, but if I would love for you to email me. You see my email down in the lower right with your feedback on this, and the question is, after seeing this information and the information you've had before today, and you're not to the realization that we need to do something about it. My question is this: what condition or what situation would you need to see to conclude that we humans have made a difference in the climate? What condition or situation would you need to act? In other words, you need to see the oceans rise 5 feet, or in Wisconsin, you need to see 20 days in a row of 110 degrees. Just what specific situation do you need to see to conclude that we have made a change and we need to do something about it? And then lastly, the requirement of me in taking the course was that I pass the information forward for the next year. So if you have any groups that would be interested in hearing about this, whether it's 3 people or 30 people or 300, please let me know. You've got my email there. So with that, I'll conclude, and thank you much for tuning in.